A function is a relationship in which each input has at most one corresponding output. In terms of ordered pairs x, y, we say that each x corresponds to at most one y. We've all seen equations like y equals 2x plus 3. So if x equals negative 1, then y equals what? So you substitute negative 1 into your equation. So 2 times negative 1 and then add 3 will give you positive 1 for an answer. If you substitute x equals 2 into the equation, 2 times 2 will be 4. Add the 3 to give you 7. And then if you substitute 4 in to the equation, you end up with 11. So is this relationship a function? That's basically asking, does each x correspond to at most one y? The way you want to look at it is, when we substituted negative 1 into your equation, we only got one answer for y. When you substituted 2 in the equation for the x value, we only got one answer for y. So you want to think about, is there any x value that when you substitute it to your equation, you get more than one answer for y? Well, we cannot do that here. So that means that each x had at most one y that it mapped to. So is the relationship a function? Yes, because each x corresponds to at most one y value. So again, there was not an x value that we substituted in to our equation to get more than one answer for y. So for example, when x was 4, we didn't get 11 and 15. We didn't get two different answers. We only got one answer each time we substituted our x value in. So in number 3, I just want you to make a quick table and sketch of the following equations and then determine if each is a function. So y equals 3 to the x. Remember that we can just do that in our calculator. And if we press our table button, that's how you enter in the equation, 3 exponent, and then the x variable key. Remember that's down here, the XYZ T button. And then press enter. And then you can look at your table. Okay, start at 0, go up by 1 each time, automatic. Okay, so as I scroll through that table, there are no x values here that give me more than one answer for y. So that means we have a function. So if you just make a quick table and a quick sketch, I'll put the answer up here so you can see that. But also go ahead and look at y equals x squared. So when you pause the video, go through and try both of those, and I'll put the answers up. So when you look at the table and the sketch of a graph, y equals 3 to the x. Okay, that's this curve here. Notice that when x is negative 2, we get 1/9 or 0.111 repeating in your, if you make it a decimal. Negative 1 gives us 1/3 or 0.3 repeating. So notice there's no x value that gives us two different answers for y. Graphically looking at that, if x equals 0, we're up here at y equals 1. If x equals 1, we're up here at 3. If x equals 2, we're up here at 9. With y equals x squared, this one's a little bit different, and this is one that people miss a lot because they notice that the y values repeat themselves. So notice how when x is negative 1 or positive 1, we get 1 for an answer. And when x is negative 2 or positive 2, we get positive 4 for answers. So does that mean that it's not a function? Well, the basic idea there is, if x equals 2, how many answers do you give me for the y value? There's only one. So that brings up an essential idea to understand here about a function. It does not matter if the y value repeats itself. So it doesn't matter that -2 and +2 in place of the x value gives you the same y value. That is okay. Graphically, when you look at that, if x equals -2, we get a y value of 4. If x equals +2, we also get a y value of 4. But we're not saying that when x equals 2, we get two different answers for y. That would not be a function. But here what's happening, when x equals 2, we only get one answer. If x equals -2, we only get one answer. When you square a number, so basically saying multiply the number by itself, you don't get two different answers when you square a number. So that is a function. So what would help to know, if we can look at a graph or a table or a relationship and say we have a function, what would not be a function? Okay, so looking at number 4. Well, what would not be a function is having an x value that goes to more than one y value. So an example of that would be a circle. Here, whatever x is, and whatever the equation is, we don't care. Let's just say x is 1 here. Notice we get a y value up here and a y value down here. So those are two different y values for the same x value. In a table of values, what would be happening is when you fill in your x value, when x equals 1, your y value might be -2 down here, and when x is 1, you might get a +2 up here. So then if x equals 1, there are two different answers you can give me. That is not a function. Another example would be a vertical line. So when you draw a vertical line such as x equals -2, when you plot points on that line, if x equals -2, we get several different answers for y. So that is not a function. And then just another quick example, like a sideways U shape. So up here we had y equals x squared, and that is a function. Down here, if we turn it on its side, so basically the equation x equals y squared, that would not be a function. Because here, whatever x is here, whatever number that is, has a y value here and a different y value down here. So those are two different y values from that one x value. So that looks at the definition of a function and how you recognize a function looking at a graph or a table.